Welcome students. Today we will understand what are quadrilaterals and then we will solve some basic questions related to it. We will be covering all the concepts of quadrilaterals and all the questions. So let's get started. So first thing is, what is polygon? So a simple closed curve made up of only line segments is known as polygon. So you can see that these are the polygons. In this the line segments are only stopped here. In this one the line segments is increased. So this is not a polygon. This is a polygon in which the line segments are closed within a curve. So this curve is not closed, so this is not a polygon, and this one is also extended towards its vertices. So this is also not a polygon. So this is what polygon is. Next one is the classification of polygons. So there are various types of polygons which depend on the number of sides and vertices that a particular polygon has. So the first polygon, which with at least 3 sides, should be there. So we have 3 number of vertices, which is a triangle, 4 is quadrilateral, 5 is pentagon, 6 has a hexagon, heptagon, octagon, nonagon, decagon. So whatever the sides are, we just have a gon suffix there. So you can remember these for your future reference. So next one is, we have like what is diagonal. So a line segment connecting two non-consecutive vertices of a polygon is known as diagonal. So here this S and Q are the vertices which are non-consecutive. So if I talk about S and P, then this particular line is not a diagonal because these are consecutive vertices. P and R are non-consecutive vertices and S and Q are non-consecutive vertices. That's why these two are diagonals. Next one, so if any let's say there is pentagon, then what are the number of diagonal will be there? So for this will 2 will not be there, so this will be having like this will be having like this. For this one, these two will not be there, so it will be having this and it will be having this. So just like you can find what are the diagonals in a particular polygon has. Next we have interior and exterior of a closed curve. As you can see, this is a closed curve. The interior has a boundary and exterior has not. As you can see that this figure is enclosed within themselves in a particular boundary, and for exterior there is no such boundaries there, so it can be extended I don't know from where. So this is the difference between interior and exterior of a closed curve. So next we have convex and concave polygon. So here we have convex as all interior angles should be less than 180 degrees, and any line segment connecting 2 points inside the polygon lies entirely within the polygon. For example, this. So here all the interior angles are less than 180 degrees. As we can see, these are 90 degrees, and any line segment connecting 2 points, for example P and R, inside the polygon lies entirely within the polygon. This is not extending towards outside. So this is a type of convex polygon. So what is concave? So at least one interior angle should be greater than 180 degrees, causing some line segments between points inside a polygon to extend outside its boundaries. For example, let's have this polygon, right? So this particular angle is greater than 180 degrees. As you can see, a straight line is 180 degrees, so this is greater than 180 degrees. So this is causing some line segments between the points inside the polygon to extend outside its boundaries. So you can see that these are extending from its boundaries. So this is the difference between a convex and a concave polygon. Next we have equiangular and equilateral. So equiangular polygon is having like all interior angles are equal. Example, square, this is the square, this equilateral triangle is there, rectangle is there. So all the interior angles are equal. So in rectangle all the angles are 90 degrees, in squares all the angles are 90 degrees, equilateral triangle all the angles are 60 degrees. So that is equiangular, means equal angle polygon. Next we have is equilateral polygon. Here all sides are of equal length and the angles between these sides are also equal. So this equilateral consists of equiangular also, where all the interior angles are of equal length, equal angle. So equilateral is having all the sides also equal and all the angles between those sides are also equal. So for example, square and equilateral triangle. Here rectangle is not there because you see in a rectangle opposite sides are equal. So all the sides are not equal in a rectangle, so that's why a rectangle is equiangular polygon, not a equilateral polygon. Next we have is regular and irregular polygons. So a regular polygon is both equiangular and equilateral, where all sides and all angles are equal. So that is a regular polygon. For example, this is a regular polygon, this is a regular polygon, this is not regular, that is irregular. So we have like hexagon is there, pentagon is there, where all the sides are equal and all the angles are equal. As you can see, this is mentioned in the diagram. And polygons that are not equal is having this, where this side is equal to this side and but it not equal to this side. So if any of the side is not equal and any of the angle is not equal, for example this and this, then that is not a regular polygon. This also, this angle is not 90 degrees, this is 90 degrees, and this two sides are equal, not equal to this side. So that's the difference between regular and irregular polygons. And now we come to that part where we have to do some calculations regarding the angles. So sum of interior angles in any polygon can be calculated with the formula of n minus 21 and 180 degrees, where n is the number of sides. For example, it is a four-sided polygon. Then we can put 4 here. So 4 minus 2 is 2. 2 into 180 is 360 degrees. So all the sum of the interior angles of that four-sided polygon is 360 degrees. Same we can find for the pentagon. In pentagon, we have 5 angles, right? So we have to put 5 here. So 5 minus 2 is 3. And 3 into 180 is 540 degrees. So the sum of all the interior angles of a pentagon is 540 degrees. In a triangle, 3 minus 2 is 1. 1 into 180 is 180. So the sum of all the interior angles of a triangle is 180 degrees. This equation will help solving some of the problems. Next is sum of exterior angles in any polygon is 360 degrees. So whether it is a regular polygon or a irregular polygon, if we have to find the sum of exterior angles, that will be always 360 degrees. For example, let's say there are 5 exterior angles and you have given 4 exterior angles and you have to find the 5th exterior angle. Then what you can do is you can have the sum of those 4 exterior angles and minus that from 360 degrees, and you can find your 5th exterior angle. Next we have each interior or exterior angle will be equal to the sum of interior or exterior angle divided by n. So that is usual thing, right? If we have to find each interior angle, so that is sum of the exterior or interior angles divided by n. This particular sequence is valid for a regular polygon, because in a regular polygon all the sides and angles are of equal length. And if you have to find each angle in a regular polygon, that is if you divide the sum of all the angles with the total number of angles. So next we come to what are the kinds of quadrilaterals. So the first one is trapezium. So what are the properties of trapezium? Is it is a quadrilateral. Quadrilateral means it is a four-sided quadrilateral with a pair of parallel sides. So it means that parallel sides are always equal. So this is parallel to this, but not this. This is parallel to this. These two are parallel. These two are parallel. But here, as you can see, none of the sides are parallel to each other. These are parallel, but as you can see, these are having 5 vertices, and trapezium is only having 4 vertices, and these are not parallel. So this is the property of trapezium. Next we have kite. So a kite is also having 4 sides. It is also a quadrilateral. So it is having 2 distinct pair of adjacent sides of equal length, usually consecutive sides. So first of all, it is having a 4 sides. So this is having 5 sides. So this is not it. This is not a kite. This is a kite where the adjacent sides, means side by sides, are of equal length. So this is equal to this. This is equal to this. These both are equal. These both are equal. These are equal. These are equal. Here you can see these are equal and these are equal, but there is an extra side is there. So that is not a kite. Here, as you can see, adjacent side should be equal. So this should be equal to this, but that is not the case. So that is not a kite. And also, as you can see, these 3 sides are equal. So that is also not a kite. Next we have is parallelogram. So this is having an interesting property. So this is a quadrilateral 4-sided polygon. Here opposite sides are parallel and are of equal length. So you will see this particular figure many times, where this is parallel to this, and these are of equal lengths. These are parallel and these are of equal length. So if you know, if any of the two opposite sides are equal, then the opposite angles are also equal. So angle D is equal to angle B and angle A is equal to angle C. So opposite sides are parallel and of equal length. Opposite angles in a parallelogram are equal, and consecutive adjacent angles are supplementary. Their sum is 180 degrees. So you can see that this angle D and angle C, so angle D plus angle C should be equal to 180 degrees because those are adjacent angles, same as angle A and angle D. So angle A plus angle D is 180 degrees, and the diagonals of a parallelogram bisect each other, meaning they intersect at their midpoint. So as you can see, in a figure, all the sides means opposite sides are equal, and the adjacent angles are 180 degrees and opposite angles are equal, then the diagonals bisect each other at their midpoint. So this will be the midpoint of this particular figure, which is parallelogram, and this side should be equal to this side and this side should be equal to this side. So as you can see, this is a parallelograms. These are not, because this is not parallel to this. This is more than 4 vertices, and this line is not parallel to this line. So these are not parallelograms, these are parallelograms. As you can see, QP is parallel to SR, QS is parallel to PR. Same in the case of this one. Next we have rhombus. Rhombus is also a quadrilateral where 4 sides are of equal length, just like a square. Opposite angles are equal, just like a square. Consecutive angles are supplementary, same as we have seen in the parallelogram. Diagonals bisect each other at right angles, so this will be always 90 degrees. Diagonals are not necessarily equal. So these diagonals are not necessarily equal because this whole diagonal is not equal to this diagonal. There may be a case where the diagonals of a rhombus are equal, but if that is equal to a square, because in a square all the 4 sides are equal and all the angles are of 90 degrees. That's why each diagonal divides the adjacent angles into equal halves. So this particular diagonal divides the adjacent angles into equal halves. So this angle is equal to this angle. So this is x, then this is also x. If this is y, then this is also y. The diagonals of a rhombus are perpendicular bisectors of one another, which I have said that this is 90 degrees. So that are the properties of rhombus. You have to note down these properties, as this can be asked in your examination. Next we have rectangle. So this is also quadrilateral, which are having 4 vertices. So this is a parallelogram, and you know what is a parallelogram? Where the opposite sides are parallel and equal, just like this. So with equal angles, so this is 90 degrees, all the angles are of 90 degrees. Opposite sides of equal angle and its diagonal bisect each other, means diagonals divide each other into 2 equal halves. So this one is equal to this one, and this one is equal to this one, as diagonals of equal length. So it is also having a diagonals of equal length. So this particular is equal to this one. So all these 4 line segments are equal. In the case of square, the same thing applies. Diagonals are equal and bisect each other at 90 degrees. So here this angle is not 90 degree, but here this angle is equal to 90 degrees. That is the difference between a square and a rectangle. So these are the properties, that opposite sides are equal and parallel, opposite angles are equal, consecutive angles are supplementary, means 180 degrees, diagonals are equal in length, all angles are in 90 degrees, which we have saw that these all are 90 degrees. Opposite angles are perpendicular, diagonal bisect each other at right angle, which is correct. Symmetry, yes. Diagonals bisect angles at vertices, no. So as you can see that these bisect each other, so this angle is equal to this angle. All sides are equal in a square, not in a rectangle, and diagonals are also angle bisector in the case of square, not in the case of rectangle. So you can note this down, the difference between rectangle and square. And next we have the comparison table of all the quadrilateral, which are parallelogram, rhombus, rectangle, square, and kite. You can have this as your reference to understand each one of the quadrilateral properties. So you can go through this table and clear your all the doubts and logics. Now in the next section we will dive into some of the questions related to quadrilaterals. We will solve some question. We will find the angles in a polygon. We'll find the number of sides. We are having some formulas to calculate each interior or exterior angle and all those things. Okay students, so let's solve some problems. So the first question is, what will be the angle sum of a convex polygon with number of sides 7? So as we have discussed, to find the angle sum of a polygon, we have a formula which is n minus 2 into 180 degrees. So n here is the number of sides. So we just have to put n equals to 7 and we will get our answer. So for 7 we have 7 minus 2 into 180, which is 5 into 180, and that will be our answer, which is 900. Now again we have 10, which is 10 minus 2 into 180 degrees, which is nothing but 8 into 180, and we have, so 8 times 0 0, it is, so yeah, this will be our two answers. Let's go to the next question. Here we have to find the x, which is nothing but the angle. So this is a polygon in which we have to find the x, in which out of 4 angles, 3 angles are given. One is 50, one is 130, one is 120. We have to find the x. And as we know, for a 4-sided polygon, we have all the sum of interior angles, which is equal to n minus 2 into 180. So if we put 4 minus 2 into 180, which is nothing but total of 360 and 360 degrees. So what we have is 360 degrees will be equal to the sum of these 4 angles. So we have 50 plus 130 plus 120 plus x, and here we have to find the x. Therefore we have x equals to 130 plus 120 is 250 and 50 is 300. So we have 360 degrees minus 300 degrees, which is nothing but 60 degrees. So we got our answer is 60 degrees. Let's get to the next question. Here, as you can see, there are 5 points in this polygon, 1 2 3 4 and 5. Here we have to find the x, and this indicates that this angle is equal to this angle. So in a pentagon, if we put, pentagon has 5 sides, so if we put 5 minus 2 into 180, we will get our answer as 540 degrees, which is the sum of all the interior angles. Now for that we have to find this angle and this angle, and as we know, in a straight line we have 180 degrees. So for this angle we have 180 degrees minus 70 degrees, which is equal to 110 degrees, and here same 180 minus 60, so 180 degrees minus 60 degrees equals to 120 degrees. So we get two angles, which is 110 120. I can write here 110 and 120, and now we have to find the x. And as we know, sum of all the interior angles is 540 for a pentagon which has 5 sides. So now this 540 will be equal to sum of these interior angles. So we have 540 equals to 110 plus 120 plus x plus 30 plus x, 30 and x. So here we get 2x, and if we solve this we get 540 equals to 120 plus 110, which is nothing but 230, and 30 260. 260 plus x and x 2x. Therefore x equals to 540 minus 260, which is nothing but 180 degrees. So 540 minus 260, which is nothing but 280 degrees. Therefore x equals to 280 by 2, which is nothing but 140 degrees. So that's our answer. Next question we have is this. We have to find x, y, z and w, the sum of these 4 angles. So what we have to do is, since we know that this x can be 180 minus 120, so we can directly write here 60 degrees. This is 180 minus 80, which is nothing but 100 degrees. This is 180 minus 60, which is 120 degrees, and this is w, which is unknown. So by looking at it, we know that these are having 4 vertices, which is a polygon, and the sum of all the interiors in a polygon is 360 degrees. So we have 360 degrees equals to this 60, 120 and 80. So 120 plus 80 plus 60 plus the unknown angle, which is this one. So the unknown angle we getting is 120. This is 200, 260. So we get our 100 degrees as the unknown angle. So we have this called 100 degrees. Now what we need to find is this W. Since it is a straight line, we know that this will be equals to 180 minus 100, which is equal to 80 degrees. Now we got our all of our angles. We can calculate x plus y plus z plus w, which is nothing but x is 60, y is 100, z is 120, and w is 80. So this becomes 200, 300, 360 degrees. So that's our answer. Let's move ahead to next question. Here what we need to find is, here we need to find this angle where these angles are given. So there is a hint. You can try to solve this question as on your own. So we are having hint as sum of exterior angles in any polygon is 360 degrees. So this is a polygon with 4 sides, right? And sum of exterior angles. So this is the interior angle, this is the interior angle, this is the interior angle, and this is the interior angle. The exterior angle is corresponding to this interior angle is 50, 90, and 110. And for this is the x. And we need to find this x. And we know the sum of the exterior angles in any polygon is 360. So from this equation, we know that 360 will be equal to this 30 plus 50 plus 110 plus x. So we have, this is 90, not 30. So 90 plus 50 plus 110 plus x. From here we get our x values as 110 plus 90, 200, 150. So we get our answer as 360 minus 250, which is equals to 110. So we get our x value as 110. Now let's come to the another question. Here it is written as, find the number of sides of a regular polygon whose each exterior angle has a measure of 45 degrees. So as we have studied that each exterior angle is equals to sum of the exterior angles divided by number of sides. Here we have to find the number of sides. So what we can do is we can shift this as here and this as here. So number of sides, let's have denoted as number of sides as n, and it is given as each exterior angle has a measure of 45 degree. So we got here as 45 degrees equal to, and sum of exterior angles, and you know that a regular polygon, the sum of exterior angles is always 360 degrees, as we have studied in our notes. So this will be 360 degrees divided by number of sides is denoted as n. Therefore n is equals to 360 degrees minus 45, and this will be equals to 8. Therefore this regular polygon has 8 sides. I hope this clears your doubt. So let's move to next question. Here we have to find the x, and as you can see, this is a 5-sided polygon, and here we have to find the x. So hint is 5 sides pentagon. You can try this to find the x on your own. So let's go. So this question can be solved in 2 ways. One is by the interior angles, and the other one is exterior angle. Any approach you can try. So let's first done by interior angle. So we know that this is given as 90 degrees, this is given as 90 degrees, and a straight line we have 180 degrees. So we know that this angle will also be a 90 degree, this angle will also be a 90 degree, this will be something, this 70, so 180 minus 70, so this will be our 110 degrees, and this is 60, then this will be our 120 degrees, 180 minus 60, which is 120. And now we have to find this angle unknown. Let's say this is y. So let's find out y first, and then we can find x by subtracting this y from 180. this is the approach of interior angle. So as you can see that we have find all the angles. So in the pentagon, the sum of all the interior angle is n minus 2 into 180, and n is 5, so 5 minus 2 is 3, 3 into 180, therefore 540 is the sum of all the interior angles, and we have our interior angle as 90 plus 120 plus 90 plus y plus 110 equal to 540. Now you can find y equals to 540. So let's calculate this. This is 200, 320, and 90 is 410. So 410, and this is 540. So 540 minus 410. This will be equal to 130 degrees. Now we have to calculate x, not y. So this is 180. Therefore our x is 180 degrees minus this y 130 degrees equals to 50. So we got our x as 50 degrees. This is the approach of interior angle. Now let's try exterior angle approach. We know that in any polygon, the sum of all the exterior angle is equal to 360 degrees. Here we have to find this exterior angle, and we should have 5 exterior angles for this pentagon as it has 5 sides. Here we are given as 1, 2, 3, and this we have easily find out as 4th angle. So we know 4 exterior angles, and we have to find the 5th exterior angle. So that's simple. So just calculate 70 plus 90 plus 60 plus 90 plus x equal to 360. This is the sum of all exterior angles. So 90, 90, 180, 180 and 60, 240, 240 and 70 is 310, 10 plus x equal to 360. Here x we got as 360 minus 310, it's nothing but 50 degrees. So any approach you can try to find the angle of any polygon. So I hope this clears your doubt. Now let's move to next question. Here we are having this question: how many sides does a regular polygon have if each of its interior angle is 165 degrees? So we know that let's go to the solution. So as we know that sum of all the interior angles in a regular polygon can be calculated by n minus 2 into 180 degrees. Here we don't know how many sides are there, and that is what we have to find. And it is given as each of its interior angle is 165 degrees. Now tell me students, if this is the sum of all the interior angles, then what will be the each interior angle is, which is nothing but if we divide this whole equation into n, the number of sides, correct? So let's say I am having 5 sides, and the sum is this n minus 2 into 180. Now if I want to calculate only one side, then I have to divide this n minus 2 into 180 divided by 5. So this is n is 5 here. So n minus 2 into 180 minus n, where n is 5. So same way we have to do here. So the equation becomes this 165. So this is the value of each interior angle, which is given as 165, and this is our formula. So if we calculate n, then we get our number of sides. So let's calculate this. So here this is the same approach as we did in our previous lecture, that we have to multiply this 180 by each of its terms. So this will be equal to 180n minus 360 equal to 165n. So if you calculate this, then 180n minus 165, which is nothing but 15n, and this minus becomes plus 360. So n becomes 360 divided by 15, which is 24. So we are having this regular polygon with number of sides as 24 sides. I hope this clears this question. Now let's come to the parallelogram section. So here it is given as BEST is a parallelogram. This is the one. Find the value of x, y, and z. So the hint is given as opposite sides are equal in the opposite sides and angles are equal in parallelogram, and the consecutive angles are supplementary. Correct? Yeah. So let's solve this. So here it is given as x, y, and z. So we know that in a parallelogram opposite angles are equal. So this B is the opposite of this S angle. So we know that x is equals to 100. So by directly we have find out that our x is 100 degrees. Now same we have to find out this z and y. Now in a parallelogram we know that the sum of interior angles is 360 degrees because it is a four-sided polygon. So we know that this is 100, this is 100, then we can easily find out z. So this z is equal to this also because opposite angles are equal in a parallelogram. So we got our 2z plus 100 and 100, and this will all be equal to 360 sum of all the interior angles. So we got our 2z equals to 360 minus 200, which is 180, and z as 180 by 2, which is 90 degrees. Sorry, this is 160 degrees. So we got our as 160 divided by 2, which is 80 degrees. And if z is equals to 80 degrees, then y will be equal to 180 minus 80, which is equal to 100 degrees. Correct? Because this is a straight line and the angle in a straight line is 180 degrees. So this is the question. Now let's go to the next question, which is the measure of two adjacent angles of a parallelogram are in the ratio of 3:2. Find the measure of each of the angles. Now here we don't have to draw any diagram because we directly know that if the adjacent angles of a parallelogram are in the ratio of 3:2. So let's think this way. We know that in a parallelogram we have four angles, right, in which the opposite angles are equal, and it has given the adjacent angles are in the ratio of 3:2. So we have, let's say this is the parallelogram, we have this as 3, this as 2. Let's take this as 3x and this as 2x. So we know that this is 3, then this is also 3, and this is also 2. So we know that if I calculate this as 3x plus 2x and then again 3x and 2x, this will all be equal to 360 degrees. Correct? Or I can say 2 times of 3x plus 2x equal to 360 degrees. So this becomes 10x equal to 360 degrees, and x becomes 36 degrees. So the measure of each of the angle in a parallelogram is 36. That's it. And if you want to cross verify if the answer you have find is correct one or not, then you can see that adjacent angles are in the ratio of 3:2. So the angles in the parallelogram are in the ratio of 3:2. So 3x ratio 2x, which is nothing but 3 into 36, which is 108, and 36 into 2, 72. So if this is 108 and this is 72, then you can easily calculate this 102, this will be 102 also, and this will be 72, and the sum of all the interior angles is 360 degrees. This is how you can verify your answer. The next question is, this HOP is a parallelogram. We have to find the x, y, and z. So this is x, this is y, and this is z. So one important thing that you would like to note here is, whenever you find a figure like z, so this is coming as z, right? This is z, right? Please make sure that this angle will be equal to this angle. It will be always. So like this is also z. This one E, H, P, and O. This is also SZ. So if we have to find y, then this will be equal to 40. This is the adjacent angle property. So if you don't remember adjacent angle, then you can easily remember this z figure property. So y is equals to 40. Directly we have find out that y is equals to 40 degrees. Correct? And if this is 70, then in a straight line we know that this will be our 110 degrees. So if we know that this is 110 and y is 40, then this will be, so this is the angle sum property, where in a triangle all the angles are of 180 degrees. The sum of all the angles is 180. So we know that 180 equals to this y plus 110 plus z. Y is coming as 40 plus 110 plus z. So we got our z is equals to, this is 150, 180 minus 150 is 30 degrees. So we got our z, we got our y. Now we have to find the x. And we know that in a parallelogram, opposite angles are equal. So from directly we can say that x is 110 degrees. Or if you need to solve this further, then we can say that if this is y becomes 40, then this z is 30, right? So this is a z figure property. So if this is 30, then this is also 30. And this is a triangle E, H and P. So this is 40, this is 30, which is 70. Then this will be 70 plus x equal to, this is a triangle, so this will be 180 and x is 110. So from any of the approach you can try and you can find out the angles in a particular polygon. Now let's come to our final question, which is a rhombus. So here what we need to find is, we have to find the x, which is a side. So we have to find the length of a side, we have to find the length of y, and we have to find the length of z. This is what you have to find. Now in a rhombus we know that all the sides are equal, right? And the diagonals bisect each other. So this is x, then this is also x, this whole, and this is also y. So if this is particular, this CO is 12, and we have to find y, which is OR, then OR equal to CO equal to y equal to 12. We find out what is our y, and this is given as 5. So this is the whole question. So we have find out that y is 12. So if this is x, then this will be the x also, because this diagonals will bisect each other. So we got our x as 5. So OE will be equal to OI, which is x, which is equals to 5. And now we got our, this x is 5, this y is 12. And if you know that in a rhombus all sides are equal, and we have denoted this with this particular symbol. So now if you want to calculate z, so if you calculate this one, this will be equal to z. And if you know Pythagoras theorem, then this is a right angle triangle with a degree of 90 degree. And if you know that in a Pythagoras theorem, this base square and perpendicular square will be equal to hypotenuse square. So what will be our answer is, for this particular, let's say z, then this will be equals to x square plus y square equal to z square, where x is given as 5 square, y is given as 12 square equal to z square. So we get our z square equals to 25 plus 144, which is 169, and z is equals to square root of 169, which is nothing but 13. So if this is 13, then this will be 13. So this is our answer. So students, I hope you got all your basics cleared regarding this quadrilateral chapter. I hope your all the queries are solved. If you have any doubt, please feel free to comment. And if you like this video, please like, share and subscribe for more. I'll see you in the next video. Thanks.
Thank you for watching. If you like it, please like, share and subscribe for more.